Hello and welcome to a Unity scripting tutorial. In this tutorial we will be going over how to make a working vehicle like the one you see here. Albeit this one is very, how should I say this? Simple. Being it's not really a model of a vehicle, but you can always replace it with an actual vehicle model once you create the actual functionality. And as you can see, I have little cubes in the middle of the tires, so you can see that the tires are indeed rotating. Alright, and we have nice little physics, and this is all using the default Unity wheel colliders. So how do we do this? Simple. Okay, I already have everything built out. That way you don't have to watch me type. And I'm just going to explain everything you see here, and I'm going to keep it nice and simple. Alright, so with that being said, let's start out with the scene. We have a directional light, which is the sun. In fact, I might as well just rename it the sun while I'm at it. We have a plane, which is the ground. And then we have the main camera. Alright, I have the main camera right here because that's where this camera target object is. I'll get into that in a minute. The first thing you notice in here, it's a depot camera, but we have an extra script on it. It's a CameraFollow script. This is the same one created by Brackeys in his smooth camera tutorial. Let me show you the code and we'll explain it. Alright, so we are now inside Visual Studio. Let me make sure it's actually in there. Yep, okay. As you can see here, we have a public transform target. That's the thing we want to look at. Public float smooth speed. That's how long it'll take the camera to move to the position that it needs to go to. Public vector 3 offset. This is how far the camera needs to be away from the target. And then we have void fixed update, because we want this to happen at a fixed interval every frame. In fact, right here Unity explains it, or Visual Studio explains it perfectly. The function is called every fixed frame rate frame if the mono behavior is enabled. Alright? It's different than update because on a slower computer it will run the same way as it would on a faster computer. So next we have vector 3 desired position. This is going to be the variable that we assign later on to determine where we want the camera to go. And that is equal to the target position plus the offset. So basically we're saying the desired position that we want the camera is equal to the same position of the target, and we're just adding the offset as how do I explain this? Okay, let's see. I'm just going to use a comment. Okay, so you have, I'm just going to use a vector 2 to explain it. Now we'll do a vector 3. So if you had a vector that's 0, 0, 0, okay, vector 3.0, and you have an offset like this, basically when we do target position plus offset, what we're telling the computer is to take this number and add this number to it. Take this number, add this number to it, take this number, add this number to it, and that is our new vector 3, which in this case would be the same as the thing right here. Well, let's say we have a 2 here and a 3 here. The output for that would be a 5. Okay? So I hope that explains that bit of vector math. So the next thing we have after the desired position is a smoothed position. And this basically makes use of the smooth speed to make it less snappy. Because when we have the camera following the player, we don't want it to just snap to the position every time. Otherwise it's going to look very jittery. So we use vector3.lerp, and lerp interpolates between 2 points. So we have vector3a and vector3b. Vector3a, in this case, is the transform position of the camera. The second position, vector3b, is the desired position variable. The value we get when we add the target position and the offset together. And then we have smooth speed, which is going to be the time, the float t, the time it takes for the camera to smoothly move from point A to point B. Okay? And then we have transformed position equals smooth position, and this actually takes the current position of the camera and sets it equal to the value of this equation. Like the answer to this equation. Okay? And then transform.lookAtTarget simply makes the camera look at the target. This. Okay? And that's exactly how that script works. Now let's go back into Unity and look at everything else. Alright, we're back into Unity. And I know this looks kind of weird because of the way the tires are rotated, but that's the only way I could figure out how to get around a weird bug I encountered. Alright. And I'll explain that later. So after the main camera, we have the player. And this is just an empty game object that's being used as a root object to hold everything that builds the car. So we have, let's go down the list. We have the camera target. That's what the camera is actually going to be looking at and how it's going to be determining its offset. Okay. And then we have the body, which is basically just a cube with a box collider on it. Alright, that's the mesh. And you can replace this box collider with a 3D model of a car. Like the model part of the car. Minus the wheels, because the wheels have to be added later so you can have them rotate. Going back to the player right quick, if you look closely, we have a CarController script and a rigid body. Okay, so let's look into the CarController script over here in the inspector. As you can see, we have this thing called axle infos, and it has a value of 2. What that value of 2 is the size of the array, which is made of 2 elements. Get it? 2, element 0, and element 1. And you might be confused, like, why doesn't it just start at element 1 and then go to element 2? Well, that's because arrays start from 0 and count upwards. So if you have an array with a size of 0, you will have nothing. But if you have an array of the size of 1, it starts off at 0. It says this is number 1. And then this is number 2, and so on and so forth. Alright? And if you look carefully inside each of these elements, we have a couple of variables here. We have a left wheel, which is the wheel collider for the front left wheel, and the right wheel, which is the front right wheel collider. And then we have two booleans, a motor and a steering. We'll look into that when we get inside the actual code. And we have the same thing on the second one. And basically, this is just a list of the number of axles. And we can have a maximum of 20 axles in the list. Alright? So, at the bottom, after the axle infos, is a max motor torque and a max steering angle. And we'll go into depth right now, because we're going to go straight into the code. And take a look. Alright, we're back inside Visual Studio. And as you can see at the top here, we're making use of the collections generic. And that lets us use the, where is it? The list, I believe. And then we have using Unity Engine, blah, 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 blah. And then you've noticed this right here, which probably confuses you. But don't worry, this will make sense right now. System.serializable just means we can see this class inside the inspector. Which is why when you go back inside Unity, and you go to the player, you have axle infos as like a little drop down. And it's a drop down because it's a list. And then inside the list, you have element 1 and element 2. I mean, element 0 and element 1. My bad. Okay, let's switch back to Visual Studio and look through this class. So as you can see, it says axle info. And axle info is comprised of a wheel collider for the left wheel, a wheel collider for the right wheel, a boolean for the motor, and a boolean for steering. So the wheel colliders, we need this information for each axle. That's right, each axle info is one of the elements. And with each axle info, or in this case, it's just the axle, we have a left wheel, a right wheel, a motor, and a steering. The left wheel is the left wheel collider for that axle. The right wheel is the right wheel collider for that axle. The motor is a boolean that tells us whether or not this specific axle will be getting force applied from the motor. So, torque. It makes the wheels rotate, like in a car. If it's front wheel drives, plural, English. Come on, brain, think. Okay. So, in a real car, if you have a front wheel drive vehicle, that means the front wheels are propelling the vehicle forward. In this case, the motor option right here tells the script, hey, this axle in particular needs to be, let me restart, needs to have force applied to it to rotate the axle, rotate the wheels. Public wheel steering, on the other hand, is telling us whether or not this axle is able to be steered by the player. So think of like in a real vehicle. If you turn the steering wheel, the front wheels of the vehicle will turn left or right depending on how you rotate it. And that's all this means. This is just saying, hey, this is a collection of information about each axle that we will go into detail later on. And then we have the actual class for this script, a mono behavior inherited class called CarController. It inherits from mono behavior because we need to be able to put this on another object as a component. So, if you look here, we now have public list axle infos. Now that can be confusing, so let's make this easier to read, okay? So instead of axle infos, we're going to call it axle if I could spell, axle list. And that just tells us, hey, this is a list of axles. And then we had the public float max motor torque. That's the first number at the bottom after the actual list of axles that we saw in the component inspector. And this tells us the maximum amount of torque that the motor can apply to the wheels, or, well, the axle. Because when you rotate the axle, you rotate both of the wheels. Public float max steering angle limits the angle at which we can steer the tires, the wheels. You don't want to turn the wheel to the left and then go 180 degrees, because then you won't actually be turning. You will just be, you'll probably do a pretty cool donut. In fact, that gives me an idea for something funny I can do later. But anyways, so the maximum steer angle the wheel can have. And now we get into a kind of scary portion. And this is where I had to rotate the wheels like this inside the editor to be able to make it work. Because otherwise, it would literally spawn like that right there. And then rotate in this direction and that direction. It was weird. And I struggled for a while to figure it out. Eventually, I had to look on the internet. But anyways, let's go back to Visual Studio and finish looking at the script. So we have a method here called public void apply local position to visuals wheel collider. that to an unexperienced programmer, that's kind of confusing. Like, what? What do you mean wheel collider, right? Well, let's look at this and break it down. So we have a public method, which means it can be accessed from other scripts outside of it. Then we have void. I don't really know what void means. I just see it as something we put there to indicate it's a method. And then we have apply local position to visuals. That's the name that we are going to use later on to reference back to this method, to call it, to trigger the method. Then we have wheel collider. And this is the confusing bit right here. Wheel collider simply means that this method accepts a collider. And we call that collider collider. And the type of that collider is a wheel collider. So it's applying the local visuals from this collider to whatever we're doing in here. So it's getting this data from a wheel collider. Okay? And then we have an if statement. If collider.transform.childCount equals 0, return. This basically just says, hey, if the collider's parent object does not have any child objects, and a child object is, if you go back into Unity, you look here, you have the player, that's the parent, camera, target, that's a child, body, that's a child, wheels, that's a child, and wheels is also a parent of front left. Front left's a parent of graphic. Graphic is a parent of tire, and tire is a parent of cube. But they're all children of each other, pretty much. So this is a child of this object. That's a child of this object. That's a child of this object. That's a child of this object. So on and so forth. Okay? Now let's go back to Visual Studio. After that, so if there is no children objects, we just return, which means we stop and don't do any of this mess down here. Okay? Ow. And then we have transform visual wheel equals collider.transform.getChild 0. This simply says, hey, we're creating a variable here, and its type is a transform. We're going to call it visual wheel because this is supposed to visually represent the motion of the colliders through a mesh that the player can actually see. And then we're going to set that equal to the collider. So we're referencing the collider we are calling earlier. Then we're accessing the transform of that collider, and that's basically saying, hey, get the parent, okay? And then we're going to say, hey, get the child object of this. So if you go back into Unity once again, and you look over here, what that script was basically saying, or I mean that line of code, is we have a variable, and we're going to be setting it equal to the first child of the wheel collider's parent. So this is a part of the front left game object, okay? And if you go down one child into the front left game object, you have the graphic. And then inside the graphic, we actually have the tire and the cube and all that. So we're going to be setting visual wheel equal to this, okay? The invisible empty game object housing the actual tire mesh, okay? And there's a reason why I did that. So going back to Visual Studio once again, we have vector 3 position and quaternion rotation. That's a big scary word, isn't it? So let's start with vector 3 position. This is simply a vector 3, so like 0, 0, 0, that's a vector 3. So we're getting the position of, we're not getting it, we're creating a variable to hold the value of a position. That's why we called it position. Then we have quaternion rotation. So that pretty much explains it. A quaternion is like a way to represent a rotation. It deals with mathematics in terms of like why it's called quaternion, but just think rotation with a little more pizzazz than something like the Euler angle, which you can look into in your free time if you want. Then you have a collider that get world pose, out position, out rotation. What this says is, hey, go to the collider, get its position and rotation in the world, and set the position of the let me rephrase that. Copy and paste the position from the collider to this variable's data. So let's say the collider's position is at 0, 0, 0. What this out position does is say, hey, take 0, 0, 0 and store it inside position. Okay? And then out rotation does something similar, but with the rotation. So it takes the rotation, the quaternion rotation of the collider, the wheel collider, and put that into the rotation variable. Okay, so we can use it later down here. And then finally, we say visual wheel that transform dot position equals position. And all that says is, hey, get the visual wheel transform that we created up here and set up here as well, and change the transform, the position, the X, Y, and Z position. So once again, back into here, go here, like click on the player, you see you have position X, Y, and Z. Back to here. There's going to be a lot of back and forth in this, by the way. So we're going to take the position from here and set this wheel's position equal to that, which is taken from the collider. And the same thing with the rotation. We take the visual wheel's rotation and set it equal to the rotation variable, which we got the data from the collider from, if that makes sense. Now, let's actually get to the actual motion of the vehicle. That's something we've been waiting for, haven't we? So in this, we're using the void fixed update because we're doing physics. A wheel collider is a physics component. You interact with the world using the physics engine. And to make sure it all runs smoothly across all devices that it runs on and isn't too fast, because if you use regular update, what would happen is, say you're on one computer and you're playing at 60 frames per second, and then your other friend has a computer and it's running at 120 frames per second. His simulation will be like several leagues faster than yours, which puts you at a disadvantage. So we use fixed update, which updates the game at a fixed frame rate, which makes sure no matter what computer you're on, even if it's weak or strong, you have the same output happening, okay, at the same speed. That's how I look at it. Then we have float applied torque. Applied torque is basically what, let me restart. Float applied torque. This is exactly what it says it is. You have the max motor torque, the input get axis vertical, and we're multiplying it together to create the applied torque. The applied torque is what is actually going to spin the wheels. And the reason why it's max torque times input is because we want the user to decide how much torque is being applied to the motor. The maximum torque for us is 400, and we're multiplying that by the value gotten from the input system. So if you're not holding down any keys, or any of the vertical keys in this case, you have a value of 0, and anything multiplied by 0 is 0. So as you know, we made the max motor torque in the inspector 400. So if you're not holding on any keys, it's 0. You're not going to go anywhere. But when you hold down the W key, you're going to get a value of 1. 1 times 400 is 400, and your wheels spin at 400 rotations. I don't know what the time scale of that is, but 400, okay? 400 is greater than 0. And then we have float steering, which is just taking the maximum steering angle and multiplying it by the horizontal input. And it's basically doing the same thing as this up here, but doing it towards the steering. So when you hold down the A key, the value is 1, and the wheels will rotate towards the max steering angle, which in this case is going to be 30 degrees. Oh, we're almost there. Don't worry, we're almost done. Then we have for each axle info, and axle list. So what that's saying is for each axle in the axle list do this. Okay, so the first axle info is the type of variable that this axle info is. Okay, because if it didn't know what that was, it'd be like, hey, is this a number? Is this a string? Is this an int? Or a float? Or double? Or a quaternion? Because the computer doesn't know. And the reason why you're saying axle info here is because this is a reference. You can reference this later. And as you know, the axle list up here is of type axle info, which references this class up here. And all we're saying is for each one of those that is inside the list, we want to do this stuff down here. In that case, let's see what's happening down here. It's fairly simple, actually. If axle info steering, which means if the little checkbox for the steering is set, then just apply the steer angle, or apply the steering variable that we got up here from the inputs, remember, to the steer angle of the wheel, which is applying towards the collider. And then we have the steering for the right wheel as well. And that's all that's doing. It's applying the steering to this steerable wheel. And then we have if axle info motor. And this is just checking to see if the motor checkbox is checked. So is it the powered axle? Is it being turned by the engine? Is it rotating based on the power of the engine? Is it pulling the vehicle forward, propelling it, spinning those wheels? Gripping the pavement. And it's literally saying, hey, set the applied torque to the, or set the motor torque equal to the value of the applied torque. So spin the wheels at this rate, which is determined by this formula. And then finally, the piece of resistance. We have apply local position visuals for both the left and right wheel, which is what actually makes the mesh spin. Now that we're done with that, we'll go back to Unity one more time. In fact, we don't really need the Visual Studio open anymore, unless you mistyped something. And by the way, all of the code is available in the description. This is based off of a tutorial from the Unity manual, so feel free to go and look at that for the code. Just remember what I'm about to show you right here, so your wheels don't look funky. So if we go into the wheels parent, see, it's all normal. It's just a holder. But once you go here, we have the actual wheel itself rotated by 90 degrees. And that's the front left wheel. But as you can see, if we rotate this, it's rotating the mesh, but it's not actually the mesh we're rotating. We're rotating the wheel collider game object. It's weird. But then you have the graphic, which is the parent of the actual mesh, but a child of the collider. And the tire is a child of the graphic object. The graphic object is empty, okay? Which means this is the graphic object. Let me just see. Okay, so now you can see it. Well, see, the graphic object is just a placeholder. we spin the graphic object to move the tire, because if we didn't, the tire would be rotating like this inside the game. Not fun. Not desired. That'd be a pretty interesting game if you made that into a game, though, I guess. But if you look here, the graphic object has default values, all 0 except for the scale, which is 1. And then on the tire, we modified the rotation to be about 90 degrees, which keeps it upright. Everything else is 0, which means it's facing that way. And then the scale, well, since it's a cylinder in the skies, it's 0.1 to make it thin enough to be considered a tire. And we do that for each of the tires, okay? I'm going to get rid of this right here because I don't really want it to have an icon. Okay, so you have the front you have the game object inside the player, or the root of the car, called wheels. It's an empty object with nothing in its components list on the inspector. Then you have each of the tires, okay? So each of the tires has a wheel collider with the default values. Okay. And then inside of each of the wheel collider game objects, you have another object called a graphic. This is just a think of it like a folder. You put something inside a folder and you can move the folder around without losing the thing that's inside the folder. Same thing here. The graphic is just saying, hey, inside this is a graphic, a mesh. And then inside the tire, inside the graphic, we have the tire, which is the actual mesh that you want to rotate with the colliders. Notice how I did put this cube here just so I could see which way the tires were rotating in the game. But notice how these tires are facing that way, forward, and these tires are facing backwards. That's because when the game starts, these on this side, oh, hold on. These on this side of the game object will rotate like that. Okay? Like snap that way once you start the game. But the ones on this side rotate the other way, going that way. Okay? And this is so the wheels actually stay straight and don't make your little car look like something from some cursed movie, I don't know. And once you have all that set up, let me show you how to set everything up. So all the wheel colliders, as I said earlier, has the default values, so you don't have to worry about messing with those unless you want something special. But on the player object, here's what we did. We go here, we type 2, we got that, and now we're here, okay? We're gonna tell it which wheels go where. So we have the first axle, which is the front, up here by the camera. And we're going to say the front left wheel and the front right wheel makes the first axle. And I'm going to make this a motor one and a steering. And then we have the rear left and the rear right for the second axle. And we're just going to leave this blank for now. It's a front wheel drive vehicle. Then you're going to set the max motor torque to something like 400 and the max steering angle to 30. Don't forget to look inside the rigid body. We need to change the mass from the default 1 to 1500. Otherwise, here's what will happen. You'll spawn the vehicle in the game, and then this will happen. Boop. Oh, well. Damn it. that's what will happen. It'll just disappear because it got yeeted into space because it's so lightweight. It ate some meat on its bones. But anyways, and the final thing, the camera transform. So, or the CameraFollow script. All you need to do is set the target to be the target object. And I keep the target object separate from the rest, so you're not looking like down like this. You're looking more forward than the rest. Okay, and then you set the smoothest speed to 0.125 or whatever you want. If you want it to be faster, increase the number. If you want it to have a slower smoothing speed, and decrease that number. Then you have the offset, which to find the right offset for your vehicle, take the camera, put it as a child of the camera target once you have it, the camera target in position, and then reset the position to that object, or I mean reset everything. And then what you're going to do is bring it back. As you can see, you're going to be using this main camera preview, and bring it back. Bring it up. We'll bring it up one. And as you can see, this is kind of what it'll look like in the game, except in the game it'll be looking downwards a little bit. Okay? But since we already did all that, I don't have to worry. And all you're really going to do is type in the value that you put in for the Y and the Z value when you're moving the camera backwards and up to have a good position for the camera when you start the game. And then the true piece of resistance, a car that you can drive around, and it's actually got some weight to it. See how the box sways to the left and right? And don't worry, you can make this car really speedy too. Okay, so we're going to go to the player right quick, and we're going to make this 1,000. So as you can see, we're moving at a rapid pace. And the only reason you can tell is because of how fast the darn cube inside. Oh, yep, we just spun out. And this is a great way to tell which axle is actually doing the work. Because when you slow down and you start to speed up, you see this one is moving faster than this one. And that's because, I mean, there's not much friction here, so you can see which one's doing the most spinning. Okay? But if you turn this to a motor one, this one will start to try to kick in as well. They're moving at a similar speed. But if you turn the steering on, then you get stuff like this, which you may have to invert the orientation of the back wheels so it's not like that, because I'm pretty sure like when there is a vehicle that has both axles able to turn, if you steer one way, the other one steers the other way, so that you get some actual turning going on. Oh, I found the edge of the map. Okay, so that's how you make a simple car. And now I'm going to show you how to turn this into an actual car with a 3D model. So right quick, I'm going to go get one, and I'll be right back. Okay guys, we're back. You can't really see this right now, so let me fix that. The only way I know to fix that is go here. No, not window capture. Hold on. There we go. Boop. There we go. That's more like it. You can see everything that's going on now. So, I have downloaded this Tocus 3D low poly car. It's on the asset star. Don't worry. Links in the description. And to actually get it into your project, what you need to do is go to Window, Package Manager, and then find 3D low poly car for games Tocus, because that's what it's called. And then you click the download button that's over here. You wait for it to download, and you click import. And we don't really need the scene. We do need the prefab though, and everything else. So let's get straight into it. So Unity is going to import it. We're going to close this window now because we don't need it anymore. Okay. So now we need to replace this monstrosity with the prefab. So I'm going to take this already done prefab. We're going to put it into the scene, but we're going to right click it and unpack the prefab completely. So prefab, unpack completely. Okay. So now we have all of this. Oh, the pain and suffering. I'm trying to sort through all this mess. So we need to cycle through it right quick and figure out what's what. So we have all the wheels right here. We're going to separate those from that. And then everything else will replace the body. Okay? So we're going to go here. We're going to set this to 0. And now, you see, we got that. And we can delete the body now. And next, we need to go to each of the wheels. As we remember, the actual tire is inside the graphic object. So this is the front left tire. So we'll take the left front and put it inside that. We're going to reset the transform. And as we remember, this one should be rotated 90 degrees. Don't know what's going on here, but we're going to see what happens. If it doesn't work, we can always mess around with the values. That's what I always say. And as you can see, I'm messing with the object right here. Basically, all you're going to do is adjust this to match that. Why is this? What did I do? Okay, let's try that. I don't know what's going on with that gray color, but I'm just going to not deal with it. So yeah, it looks like this might already be oriented correctly, because when you reset it, it does that. So we'll just see what happens when we get all this done. So the front right, we're going to delete that one. We're going to take the front right, move it to graphic, reset its position. Yeah, it looks like it's going good. Okay. And then we're going to take those two, delete them, put graphic, the left back and the right back. We're going to reset both of their positions. Okay, let's see what happens when we click play. It's not going to be in the right spot. Okay, we got some interesting stuff going on here. And that's probably because the Tokus doesn't actually have any collider. So we need to get a collider. There's a couple different types of colliders. I'm going to see if there's a mesh available. Tokus body physics. There we go. And we're going to make sure it's convex to limit the thing or whatever. And let's see what happens now. See? Now the wheels aren't in the right position. That's hilarious. So let's fix that, shall we? Okay, so both of the front wheels need to be moved forward. I'm going to adjust the snap settings. And there's this little button up here called increment snapping. We're going to say 0.05 for this. I want to be precise. I think that's a good spot. Now for this part, we need to move it in like that. Negative 0.8. We'll do 0.8 on that side. And then on both of the rear ones. So we need to go negative 0.8. And then 0.8. And then the rear ones, we need to bring it back. So, like that. And then we need to bring these down. And let's see what happens there. Still a little off. But another thing we need to do is adjust the radius. And that's what we're going to do in play mode so we can see the radius in real time. 0.32 looks like a good size. Wouldn't you say? So we're going to go here. We're going to say 0.32. And then we're going to bring it up a bit. We're going to bring the left side to negative 0.5 and the right side to 0.5. Let's see what happens here. Too far inwards. Alright. Bet. So maybe a 0.6. Negative 0.6. Let's try that one. That's getting there. Oh. And that brings up a new issue. But I still want to fix this, so I'm thinking maybe a 0.65 and a 0.65. Might need to lower the wheels a bit. Nope, I think that's good. Now here's the next problem. Weep. And there's a reason for that. The center of mass is too high on the vehicle. We need to lower it. So what we can do is, instead of having like just that as the weight, we need to create a new game object that's just going to act as a center of mass. Okay, I think this is how I fix it. I don't remember. Let's see. And we're just gonna make this another 1,000, and we're going to keep it as low as possible. See what happens now. As you can see, the car is less likely to flip as often. Famous last words. Okay, let's restart that. Let's edit the value, see if it actually keeps the vehicle from flipping. Nope. Okay. So the center of mass isn't doing anything. And I still think that's because it's all the way up there. See, right now, all the center of mass is like up here. But there's something we can look at inside the wheel colliders themselves. It's called force app point distance. Let's see what happens if we center it in the wheels. As you can see, it handles it a little bit better. But once you get up too high, the wheels, it's doing pretty good actually. But still not good enough for a car like this. It's like a town car. It should have pretty good control. So let's bring it up to 0.5. See what happens then. Looky there. That's much better. And that's how you fix that rolling issue. And the reason why it was doing that, as I said, the center of mass was too high, so it was top heavy, and it was like, hey, force goes. Brrr. Okay, enough with the memes. So the next thing, I mean, that's pretty much everything you really need, I guess. And then maybe another video, I will go over how to do something like engine sounds or the speedometer. It depends on what you really want. And one thing you could do, since this car has an interior. Ooh. Okay, so what I think I'm going to do, we're going to take the camera target and make it in front of the car, like so. Okay? And we're going to take the camera, we're going to take it here, we're going to reset it. We're going to increase the near clipping. Get that nice first person experience. Except I want this to be further that way. There we go. Negative 0.04, negative 0.21. That's the value we need for that. 0.04, 2.1. Make sure that's a negative. And then we need to reset the camera. Oh, we don't really have to, but I'm going to do it anyways. And we're going to see what happens. Boop. Okay. Not exactly what I had planned. What if we put it actually inside the camera target? Nope. Ooh, I got an idea. So we're going to set the camera target to be 0, negative 0.04, negative 2.1. Oh wait, that's that's not gonna work with that one. We gotta move it up. I want it to be like right there. Oh, we're just trying to experiment, have a little fun before I end the video, you know? Yeah, bring it up. And what we're going to do is set this to 0. Let's see what happens. Okay, that's not going to work. But if you wanted the first person experience, I suppose what you could do is like just yeet this camera script. Get rid of it. I mean, yeah, you have a camera. How far do you need to go back? Pretty damn far to be able to say, ooh, physical camera. Oh my goodness. That's pretty cool. But anyways, let's undo all that work. The power of the undo. How far back does it go? I think that's right. Let's make sure. Well, I think it crashed on me. But that is how you make a working, let me just boop, boop. That's how you make a working vehicle controller script in Unity. I know this was a long one, but the goal here was to make it simple. Oh well, yep, it did crash. Whoops. Boop. Hold on. Huh. Okay. Well. Hoop-dee-doo. Well, anyways, thank you for watching. Like, comment, and subscribe. And yes, I do plan on finishing the Life of a Utah Raptor. Yes, I will finish that. Just give me a moment.